Hey guys, welcome back to my channel. In this video, I'm going to be going over trigonometry and essentially the formulae that you need to know to find the length of a side or to find an angle. So, this is a very important slide, so I suggest you take a screenshot of it, maybe print it out, stick it up on your wall, because these formulae are going to be very important to you in all your GCSE papers. The way these formulae work is it's a combination of two sides and an angle. So that way, if you're looking for an angle and you have two sides, you just have to figure out which two sides you have, and then you know which formula to use. And I'll explain what each of these sides mean. So you have the opposite here in blue. The opposite is essentially the side that's not touching the angle. And obviously, it's a side that's opposite the angle. So it's fairly easy to remember. It's literally in the name, opposite. Then you have the adjacent, which is the side that's not the longest side of the triangle, but it's a side that's touching the angle. So you can see here in green, you have the adjacent. And as I said, the longest side on the triangle is the hypotenuse. Now there's a simple way to distinguish between the hypotenuse and the adjacent if it's not clear which one is longer. Essentially, the hypotenuse will always be opposite the 90-degree angle. So you can see here with the little black box, that's a 90-degree angle, and the hypotenuse will always be opposite that. And that's how you can distinguish these sides. Now you have these three formulae, and what I've done here on the right hand side is I've written them in the form of a formula triangle. If you don't know how these work, essentially, if you're trying to find, say, an angle, then you cover the S, so sine theta, and you're left with O and H, and because O is above the H, you do opposite divided by the hypotenuse. Similarly, if you're trying to look for the opposite, then you do sine theta times the hypotenuse because they're next to each other. That's how formally triangle work, and that's what gives us the acronym TOA, so SOH, CAH, TOA. And I very much suggest that at the start of your paper, you just write these out on the top of your page. That way you remember them throughout the exam. If you ever need to look back, they're right there. So here's a simple question that you could get, just a 2-marker. The first thing you want to do when you approach a question like this is mark out what you have. So we have the opposite here, which is 20 centimeters. We're looking for the hypotenuse. As you can see, it's opposite the right angle, so it's the hypotenuse. And we have the angle 35 degrees. So because this is the combination that we have, we know we have to use sine theta formula. And because we're looking for the hypotenuse, we cover the h with our hands, and we see it's O over S, so that will give you opposite over sine 35, and that gives us 34.9 centimeters to 1 decimal place. So this is a slightly harder question. This is more like what you could get near the end of the paper, and you want to try and score 4 out of 4 on these because they're actually not that hard. They're 4 easy marks. So here we have a triangle that they have split into two for us, and they've marked out two sides and an angle. We want to find out the size of the angle BCD. So in this, we have to first start by marking out that angle so we know what we're looking for. And if you can note, if you've seen it already, you can already see the fact that we're missing a side. We have 22 centimeters, but that's the entirety from A to C. But if you look at the triangle BCD, we only have one side and one angle that we're looking for. What we want to do first is we want to find out the length DC. So we're going to use here the tan theta formula because we have 37 degrees and we have 9 centimeters. And we're trying to find out the length AD here, so we can subtract that from 22. So what we get here is the length AD is equal to 9 over tan 37. So that's the opposite, which is 9 over tan 37. And that gives us 11.9 something something something. And now what we do is we just do 22 minus 11.9, and that gives us 10 point something something. And remembering to use exact values, so when you enter in your calculator, you can save values into the letters. I'll do a video on how to get the best out of your calculator soon, so make sure you're subscribed for that. And now what you do is, because you now have the length DC, you also have the length BD, you can now find out the angle theta, which is just tan theta equals 9 over 10 something something something. And the reason why this is so important now that I'm saying that you use the exact value is because, as you can see, you don't get 0.9, you get 0.894. So it does make a difference. And luckily here we only had to use a tan formula, but sometimes it's likely that they might give you a different angle that you're looking for. They might ask you for angle DBC, for example, and in that case you wouldn't be able to use the tan theta formula. You would have to use the sine formula or the cos formula, etc. So now if you just do the inverse of 0.894, you get 41.8 degrees. So that's pretty much the gist of trigonometry and how that works. Then the main thing here is just to remember the formulae. That's why I say write it down on the top of your page when you start the question paper. TOA, a very easy acronym to remember, and always mark out the lengths that you have. In this question I didn't do it, but I would suggest that while you're getting used to sort of how each formula works, you mark out the opposite, you mark out the hypotenuse, and then you match it to which formula you can use. So if you have the opposite and the hypotenuse, you're trying to look for angle theta, then you know it's a sine formula. Thanks for watching. Good luck for your GCSEs. And if you want me to go over any specific topics, do let me know down in the comments below. If you want me to clarify on anything more, do ask me questions and I will answer them all. Thank you.